Hello, you're welcome to our chemistry class. In chemistry today, we shall be looking at the topic redox reaction and oxidation number. So we shall quickly introduce what it is all about, and then we will learn to calculate oxidation number of elements. So what does the word redox mean? Redox, red from redox means reduction, while ox over here means oxidation. Most chemical reactions undergo this complementary reaction at the same time, meaning that as one element or substituent is donating electron, the other one is accepting the electron. Reactions such as neutralization reaction, precipitation reaction, and the likes. For instance, if you have a neutralization reaction such as sodium hydroxide reacting with hydrochloric acid to form a salt, that is NaCl plus water. Each of the elements here have their oxidation number. For instance, sodium has +1, oxygen has +2, hydrogen over here has +1, hydrogen here has +1, chlorine here has -1, sodium here has +1, chlorine here has -1, hydrogen has +1, and oxygen has -2. And so we will find out that the oxidation number of these elements are unchanged, except in certain situations, which we are going to look at the rule shortly. Now, redox reaction can be explained in different ways. Now, we could explain redox reaction in different ways. Number one, in terms of addition or removal of oxygen and hydrogen, or we could explain it in terms of addition or removal of electronegative and electropositive elements, or we could explain it in terms of oxidation number, and lastly we could explain it in terms of electron transfer. So let's look at this. In terms of addition or removal of oxygen and hydrogen, let's take this equation as an example. Copper oxide reacting with hydrogen gas to produce copper plus water molecule. Here we have a solid, we have a gas, we have solid, and we have a gas, that is steam. This copper oxide is carrying oxygen, and over here the oxygen is no longer there, but here hydrogen is here without oxygen, but over here it has taken the oxygen from the copper, meaning that this copper is termed to be an oxidizing agent because it is ready to give oxygen to hydrogen. So if this is an oxidizing agent, meaning that this hydrogen is a reducing agent. See this copper oxide now, which is an oxidizing agent here. Now when it donates the oxygen to hydrogen to become copper, we will say that it has undergone reduction reaction, and it means that it has been reduced. Like this hydrogen gas that took the oxygen to become H2O is said to have undergone oxidation reaction, and then it means it has been oxidized. As you can see here, it has been oxidized to H2O. So that is the idea behind the addition or removal of oxygen or hydrogen. There are times whereby there may be no hydrogen there, as far as the oxygen is transferred from the one that has it to another one that does not have it, or the oxygen is transferred from one that has more to one that has less. All these are applicable. Next, we want to consider oxidation and reduction in terms of addition or removal of electronegative or electropositive elements. And so we'll be asking that what are electronegative elements or what are electropositive elements? We'll find out exactly what those are in few minutes. Alright, so for instance, we have iron 2 chloride reacting with chlorine gas to form iron 3 chloride. We have aqueous here, we have gas, and we have an aqueous substance over here. Now from here, chlorine is electronegative, and when electronegative elements is added to a substance, so when electronegative elements such as this is added to a substance like this, we will term it as oxidation. And it means that this particular iron 2 chloride has been oxidized. and as far as it has been oxidized, it is called a reducing agent. Now the electronegative element here is chlorine. This electronegative element is an oxidizing agent, and in this case it is the one that went through reduction, hence it is reduced. Now you find that this follows the process of the first one. We have reduction reaction, reduced, and we have oxidizing. Next we will consider redox reaction in terms of an increase in oxidation number or a decrease in oxidation number. Let's take an instance where we have zinc reacting with copper ion to form zinc ion plus copper. We have aqueous, and we have solid over here. Now you will be asking that, but there's an increase in oxidation number, decrease in oxidation number. Is this really a redox reaction? Yes, because we have this in a stable form. It is not combined with another element. But here we have this copper ion which is combined with another element. That's why we have it as Cu2+. Likewise the zinc over here is also combining with another element. And this copper here is not combining with any other element. And we'll have that the oxidation number of zinc here, which is not combining with any element, is 0. The oxidation number of copper here is 2+. The oxidation number of zinc here is 2+. And the oxidation number of copper here is 0 because it is not combining with any element. There is an increase of the oxidation number of zinc from 0 to 2+. Hence, it has undergone oxidation. And because it has undergone oxidation, it means that it has been oxidized. And also that it is a reducing agent. Then we have copper, which was Cu2+. It had reduced from +2 to 0. It means that it has undergone reduction reaction. It means that it has been reduced, and so it is an oxidizing agent. So that is the trick about increase in oxidation number and a decrease in oxidation number. Alright, so next we shall be looking at oxidation in terms of electron loss and electron gain. If you have a reaction between hydrogen sulfide plus chlorine gas to produce sulfur plus hydrogen chloride. Now we need to balance this equation. When we place 2 over here, that has balanced the equation. Now the next thing is that we need to get the oxidation number of each of the elements in this reaction. Hydrogen has +1 and sulfur is using +2 oxidation number. Chlorine over here is 0 and sulfur over here is 0. Hydrogen chloride, hydrogen is +1 and chlorine is -1. Now you find out that when chlorine is not combining with another element, it has an oxidation number of 0. But when it is combining here, it has -1. While sulfur has -2 when it is combining with hydrogen, but it is 0 over here. So it means that there is an increase or a decrease in oxidation number in one way or the other. Now let us consider for sulfur. For sulfur, it has S2-, that's the oxidation number. This 2- here means it is capable of giving off 2 electrons. And so when it gives 2 electrons, it will become sulfur. And this sulfur has oxidation of what? 0. Then, when we consider chlorine over here, it has 0 as its oxidation number. And for it to become -1, it means that it must have accepted 2 electrons. So when it accepts electron, it will become Cl-. But from here we have 2 atoms of chlorine, and so we'll place a 2 over here, and then we'll place 2 over here in order to balance it. So from here it shows that sulfur lost electrons, and so because it lost electron, we will have it that hydrogen sulfide has undergone oxidation reaction. Why? Because it has lost 2 electrons in order to become sulfur solid. So as far as it has undergone oxidation reaction, it means that it has been oxidized, and it means that it is also a reducing agent. And then we move on to chlorine. Chlorine over here gained electrons. Hence, it means that it has undergone reduction reaction. Hence, it was reduced, and it is also an oxidizing agent. So redox reaction is defined in terms of electron loss and electron gain, because it embraces other ways of defining redox reaction. What are oxidizing agents? They are substances which transfer or supply oxygen, or they remove hydrogen or accept electrons. And examples of oxidizing agents include oxygen, sulfur, fluorine, chlorine, concentrated tetraoxosulfuric acid, concentrated triazonitrate 5, potassium tetraoxosulfate 6, potassium tetraoxochromate 7, etc. Now, reducing agents are those substances which transfer or supplies hydrogen, or they remove oxygen from a substance or loses electron. And examples of reducing agents are hydrogen gas, carbon 2 oxide, active metals, sulfur 4 oxide, ammonium, hydrogen sulfide, etc. What do we understand by oxidation number? Oxidation number is the charge on an ion, or it is the number of electrons on the valence shell of an atom. There are rules for calculating the oxidation number of elements. So the first one says that the oxidation number of an ion is the charge on it. For instance, Na+, the oxidation number of this sodium ion is +1. Or you could have Cl-, the oxidation number is what? -1. Or you could have SO4 2-, which is a radical. The oxidation number here is -2. Rule 2. The sum of the oxidation number of all the atoms in a compound adds up to 0. For instance, if you have H2SO4, the oxidation number of this compound equals to 0, because if you consider each of the oxidation number, we'll add it up to 0. For instance, hydrogen has +1, sulfur over here has +6. Alright, so we have that the oxidation number of oxygen here is -2. Now from here, we have 2 atoms of hydrogen. So we have 2 multiplied by 1, because 1 is its oxidation number. Then for sulfur, we have just 1 atom, so +6. Then plus oxygen, it has an oxidation of -2. And then we have 4 atoms of it, so we have times 4. 2 times 1 gives 2, plus 6, plus -2 times 4, that gives us -8. So we have 2 plus 6, plus times minus is -8. So 2 plus 8 gives 6, 2 plus 6 gives 8, and then 8 minus 8 gives 0. So that is the second rule. We have a third rule which says that an element in its free state has oxidation number of 0. So the third one, any element, oxygen, hydrogen, sodium, in their free state has an oxidation number of what? 0. Rule 4 says oxidation number of hydrogen in a compound is +1, but it is -1 in hydrides. So if you have hydrogen in compound of sodium hydroxide, the oxidation number of hydrogen over here is +1. But if you have it in a compound of calcium hydride or potassium hydride, the oxidation number of hydrogen over here is -1. Rule 5. Oxidation number of oxygen in a compound is -2, but it is -1 in peroxides. So it means that if you have sodium hydroxide again, the oxidation number of oxygen is -2. But if it is in a peroxide such as hydrogen peroxide, its oxidation number is -1. Rule 6 says that the oxidation number of alkali metals is +1 in their compounds. Examples of alkali metals, we have lithium, sodium, potassium, cesium, etc. These alkali metals which occupy group 1 have oxidation number of +1. A seventh rule says that the oxidation number of alkali earth metals is +2. So alkali earth metals such as beryllium, magnesium, calcium, barium, etc. These are called alkali earth metals and they occupy group 2A. They have an oxidation number of +2. And the eighth one says that the oxidation number of halogens in their compounds, now take note, in their compounds is -1. Examples of halogens are fluorine, chlorine, bromine, iodine, astatine, etc. Now in their compounds such as sodium fluoride, sodium chloride, they have an oxidation number of -1. We want to determine the oxidation number of nitrogen in each of the following substances. A. N3-, B. NO2, C. NO3, D. HNO2, E. NO, and F. HNO3. And so from here we'll determine the names these compounds are called. So let's take the first one, N3-. So from here it's so obvious that its oxidation number is -3 because that is the charge, or that is the number on top of it. B, we're given NO2. We want to determine the oxidation number of nitrogen. Now all through these compounds the oxidation number of oxygen is -2, and so we do not know the oxidation number, that is the number on top of this oxygen. And another thing we need to know is that this compound, the sum of the oxidation number of this compound equal to 0. We do not know the oxidation number of nitrogen, which we take as X, and the oxidation number of oxygen in all these compounds are -2. So we'll take that X plus oxygen, which is -2, times 2, because we have 2 atoms of oxygen there, equal to 0. Hence we have X plus -2 times 2, which gives us -4, equal to 0. Plus multiplied by minus gives us -4, equal to 0. So X equal to, when you bring this -4 over here, it becomes 4. Hence the oxidation number of nitrogen over here is +4. And that is why this compound is called nitrogen 4 oxide. So we are looking at the third one, which is NO3-1. So NO3-1. This particular radical has an oxidation number of -1. That is the oxidation number. But we do not know the oxidation number of the nitrogen, but we know that of oxygen. Now we can't just take we can't take +4 or -3 as its oxidation number. And so for nitrogen we represent it with an X, plus for oxygen is -2 multiplied by 3 equal to -1. So we have X plus -2 times 3, that gives us -6 equal to -1. So X plus times minus gives us with -6 equal to -1. So we have X equal to -1 plus 6, because it's -1 turns to +6. So -1 plus 6, that gives us with 5. D, we have HNO2. This is an acid but a weak one. The oxidation number of this compound is equal to 0 because the oxidation number of hydrogen is +1. So we have it as 1. Plus for nitrogen we do not know, so we represent it with X, plus oxygen, which is -2 multiplied by 2 equal to 0. So we have 1 plus X, then we have -2 times 2, that gives -4. The -4 times plus, that will be -4 equal to 0. 1 minus 4, we have -3 equal to 0. Hence X equal to 3. And so E, we have NO. The oxidation number of this compound is 0. For nitrogen, the oxidation number is unknown, so we represent with X, plus oxygen, we have it as -2 equal to 0. So X minus 2 equal to 0, hence X equal to 2. So the oxidation number of nitrogen in this compound is +2, and so it is called nitrogen 2 oxide. F, we have HNO3, which is a strong acid. The oxidation number of this compound equal to 0, and so we equate all to 0. Now for hydrogen, we have 1 as its oxidation number, that's +1. Nitrogen is unknown, we represent it with X. Then for oxygen, we have -2 multiplied by 3 equal to 0. So we have 1 plus X minus 2 times 3, that gives -6. The -6 times plus, we have -6 equal to 0. We'll bring like terms together. 1 minus 6, that will be X minus 5 equal to 0. Hence X equal to +5. So that is the oxidation number of HNO3, and so it is called trioxonitrate 5 acid. Next, we want to determine the oxidation number of the underlined element. A, SO4 2-, we have S underlined. B, H2SO3 with S underlined. KMnO4 with Mn underlined. MnO4 with Mn underlined. And K2Cr2O7 with Cr2 underlined. So let's take the first one. A, we have SO4 2-. Here, this radical has -2 as its oxidation number. Now for sulfur, we do not know it because that is what we are looking for, and so we represent that with X. Plus oxygen has -2 as its oxidation number, multiplied by 4 equal to -2. So we have X -2 times 4 gives -8, and then -8 times this plus gives us -8 equal to -2. And so we have X equal to -2 plus 8. So we have that X equal to -2 plus 8, that is +6. So the oxidation number of sulfur there is +6. So it is called tetraoxosulfate 6 ion. B, we have H2SO3 with sulfur underlined. In this compound, the oxidation number is 0. Hydrogen has +1 as its oxidation number, multiplied by 2 because we have 2 atoms of hydrogen, plus sulfur, which is unknown, so we could represent that with S, plus oxygen. Oxygen has -2 as its oxidation number, multiplied by 3 equal to 0. 2 multiplied by 1, that's 2 plus S, -2 times 3, that gives -6. -6 times this plus, we have -6, and that's equal to 0. So we bring like terms together, we have 2 minus 6, which will give us -4. So we have S minus 4 equal to 0. So S equal to +4. Hence the oxidation number of sulfur is +4. And so this compound is called trioxosulfate 4 acid. We have the next one, which is KMnO4. Here, oxidation number of this compound equals to 0. Now, potassium, we are to find the oxidation number of manganese. The oxidation number of potassium is +1. So we have 1 plus manganese, which is unknown, so we could represent that as Mn, plus oxygen, which is -2 multiplied by 4 equal to 0. Now from here, we have 1 plus manganese -2 times 4, that gives -8. And -8 times this plus, we have -8 equal to 0. We bring like terms together, that is 1 minus 8, that gives -7. So we have manganese -7 equal to 0. Hence, the oxidation number of manganese is +7. And so this compound is called potassium tetraoxomanganese 7. D, we have MnO4-. We are to find the oxidation number of manganese. The oxidation number of this radical is -1. And so we'll have that manganese, which is what we do not know the oxidation number, plus oxygen, which has -2 multiplied by 4 because we have 4 of it. Now this minus is for this entire compound, all right, so equal to -1. So we have Mn -2 times 4, that gives -8. So -8 and times plus, that is still -8 equal to -1. Hence So we have that Mn equal to -1 plus 8. So we have plus 7. Hence, the oxidation number of manganese in this compound is plus 7. And so it is still called tetraoxomanganese 7 ion. E, we have K2Cr2O7. The oxidation number of this compound equal to 0. Now, for potassium, we have 1 as its oxidation number multiplied by 2, plus we are after chromium, and the oxidation number of chromium here is unknown, so we have X multiplied by 2. Then oxygen has oxidation number of -2 times 7, which is equal to 0. Here 1 times 2 gives us 2, plus 2x minus 2 times 7 gives -14. -14 times plus is -14 equal to 0. So we bring like 10 together, that's 2x minus 14 plus 2. So this is 2x minus 14 plus 2, that is -12 equal to 0. Now we bring this over, we have 2x equal to 12. And so x equal to 12 divided by 2, and that is 6. So with that, we have that the oxidation number of chromium is plus 6. And so that's why this compound is called potassium heptaoxochromate 6. Here's the next question. Consider the following redox reaction. Which of this species is I oxidized, II the reducing agent, III reduced, and IV the oxidizing agent? Now we are aware that any of them that undergoes oxidation is said to have been oxidized, and so it is a reducing agent. And any of the compound or species that undergoes reduction is said to have been reduced, and hence it is the oxidizing agent. And so let's take the first one. A, CuO plus CO to give copper plus CO2. Here we have solid, we have gas, we have solid, and then we have gas. This is a reaction, and in this reaction we want to determine the one that is oxidized. Alright, so let's do that by determining their oxidation number. In this compound, the oxidation number of oxygen is -2, and copper here is +2. So +2 minus 2, that gives us 0. Oxygen over here is -2, and so that means carbon over here is +2. Copper over here has an oxidation number of 0. Then over here, oxygen has an oxidation number of -2, but carbon here does not have +2. Rather, it has +4. I know you may ask me how. You have CO2 with an oxidation number of 0 as that's the oxidation number of this carbon 4 oxide. Now if we have X for carbon, which we do not know, let's say, plus oxygen is -2. So -2 times 2, which is equal to 0. So X minus 2 times 2 gives us -4. So -4 times plus, we have -4 equal to 0. So X equal to 4. That's why carbon here has an oxidation number of what? Of +4. Now taking a very good look at this, we have copper, which was +2 here. The oxidation number has reduced to 0. Oxygen has not reduced at all. Right here, carbon has +2, but it has increased to +4. So from this, we would say that, now let's take this copper oxide. So is this oxidation number of copper reduced from +2 to 0? Hence, we will say that it has been reduced and it has undergone reduction, and also that it is an oxidizing agent. Next, we have CO, that's carbon monoxide. Carbon has +2 and it has increased to +4 over here. And so because of that, we will say that CO has been oxidized and it has undergone oxidation reaction, and it is a reducing agent. As simple as that. Alright, so next we have KOH plus H2SO4 to give K2SO4 plus H2O. We need to balance this equation, and potassium here is 2, so we have 2 over here. And with this, then for hydrogen, we have 2 hydrogen, we have 2 here, making 4 hydrogen atoms. we have just 2 hydrogen atoms here, so we place 2 over here, so making that we have 4 hydrogen atoms. Next, we want to write out the oxidation number of each of the elements. Potassium has +1, oxygen has -2, potassium has +1, oxygen has -2, and hydrogen has +1. Hydrogen over here has +1, sulfur has +6, oxygen has -2. Potassium has +1, sulfur has +6, and oxygen has -2. Over here, hydrogen has +1 and oxygen has -2. So when you consider this equation closely, potassium has +1 and it's still +1 here. Oxygen has -2 and it's still -2 on the other side. We have +1 for hydrogen and it's still +1 over here. We have +1 for hydrogen here, likewise over there. Sulfur is +6 and it's still +6. Oxygen is -2 and oxygen is still -2. So from here, the oxidation number of each of the atoms remain unchanged. Therefore, the reaction is not a redox reaction. So all neutralization reactions and precipitation reactions are not redox reactions, just as we have said earlier. So we have that not a redox reaction. Let's look at another one where we have silver ion plus chlorine produce silver chloride. Here we have aqueous, and we have solid. The oxidation number of silver here is +1, for chlorine is -1, for silver it is +1, and for chlorine it is -1. Now from this, the oxidation number of silver did not change. The oxidation number of chlorine did not change. This is an example of a precipitation reaction, and so because of no change in the oxidation number, it is also not a redox reaction. Alright, so next we have this, that's Cr2O7 2- plus 14H plus aqueous plus 6 electron to give chromium 3 plus 7H2O. This equation is balanced because we have 2 atoms of chromium, we have 2 of it here. Then we have oxygen, which is 7 here, and we have 7 oxygen atoms. We have 14 hydrogen, and we have 2 times 7, 14. Check our video on redox equation to understand what this 6E- is about. Now we need to consider the oxidation number of each of these elements. Here is chromium. Chromium has +6 as its oxidation number. Oxygen has -2. Hydrogen has +1. Over here, chromium has +3. Hydrogen has +1 and oxygen has -2. So when we look at it closely, chromine, which was +6, has reduced to +3. -2 remain unchanged for oxygen. Likewise, +1 of hydrogen remain unchanged. So from here, since there is a reduction in the oxidation number of chromium, we will say that Cr2O7 2- is reduced, and that means it has undergone reduction reaction. Hence, it is an oxidizing agent. Next, we have hydrogen over here. Though there is no change in its oxidation number, but there's another way in which we can determine whether it has been oxidized or reduced. Here we have hydrogen, which is standing alone, and when it came here, it has taken up oxygen from chromium, meaning that it has been oxidized, so it has become H2O. So because of that, we will have it that our H plus was oxidized to H2O. Hence, it has undergone oxidation reaction, and so it is a reducing agent. This is how we determine the compound or the species that has been oxidized or reduced in a compound or in an equation.